Welcome to our tutorial for question 14 of our weekly review. Question 14 is asking us to use the Pythagorean theorem, and whenever we're working with the Pythagorean theorem, we know we're going to be working with triangles. Because the Pythagorean theorem describes a special relationship between all three sides of a right triangle. So if I'm being asked to use the Pythagorean theorem, I know I'm going to be working with a right triangle because that's what this is. It's a relationship between the sides of a right triangle. And we can actually use this Pythagorean theorem. It provides us a way to find a missing side of a right triangle. And actually later in math, you'll also learn how we can apply principles of the Pythagorean theorem to also find out what angles of a missing or of a right triangle are. But we're going to start off by just understanding and knowing what the side lengths of a right triangle are. So please remember, Pythagorean theorem only works when we're talking about right triangles. It doesn't work for all triangles. And a reminder that right triangles are triangles that have 90-degree angles in them. And the Pythagorean theorem states that for any right triangle A, B, and C, and so you can actually see that I created a right triangle down below with the side lengths of side A, B, and C. And the Pythagorean theorem is actually talking about a relationship about the areas of the squares that would be made up from the sides of the right triangle. And so the Pythagorean theorem tells us that for any right triangle A, B, and C, the side A squared, if I take that bottom side and I turn it into a square, plus the side C squared, if I take that side and turn it into a square, it will always be the same as the biggest square that's there, or C squared. So our Pythagorean theorem is A squared plus B squared is equal to C squared. Now, in this particular triangle, we can apply this to find the missing side length of this particular triangle. So, for example, I could simply count the sides of this triangle, and I could see that the orange side would equal 9. And I could also count and see that the blue side is going to equal 3, but I can't count that purple side because it's kind of going at an angle. So that would tell me I have an unknown side. Well, I can use the Pythagorean theorem that says that A squared plus B squared is going to equal C squared. So I can simply write this out. 9 squared plus 3 squared must equal C squared, according to the Pythagorean theorem. And I can start to work this math out. I know that 9 squared is 81, plus 3 squared is going to be 9, and that has to equal C squared. Then I can put those two sides together, or the squares of those two sides together. That would give me 90 is equal to C squared. Now, I have one last step that I can do here because I don't have the side length of my triangle yet. What I have is I have the area of the square that side length would make up. So in order to find that side length, I would need to find the square root of that side. So in this case, I would say that the square root of 90 was equal to C. Now, if you look at question 14, it asks you to round your answer to the nearest tenth. In some instances, like we just had, you're going to end up with an irrational answer. So the square root of 90 is an irrational number, and so the most accurate way we can write that is the square root of 90. But we would actually want to round this answer to the nearest tenths place, which is going to be 9 point something, and you could round it to that nearest tenths place. If you're not sure how to calculate and use our calculator to find square roots of things, we reviewed that in question 1 of our weekly tutorial that talked about irrational numbers. So you can go back and review that there. let's go ahead and take a look at another example that we might have. Before we do that, though, if you're going to write a note down for this problem, the key is that a squared plus b squared is equal to c squared, because that is what the Pythagorean theorem tells us. So let's take a look at this triangle. Here I have a triangle, and I'm going to notice right away that this is not going to work. And it's not going to work because it's not a right triangle. I don't have any 90-degree angles in this triangle, so I can't actually apply the Pythagorean theorem in this instance. However, I did want to create a triangle that was different than that. So if I ended up with a triangle like this, right, that is still a right triangle because it does have a 90-degree angle there. And again, I could apply some information in this particular problem. Now, I'm going to give us the side length. This time I'm going to tell us that A is equal to 6 and that C is equal to 10. This looks a little bit different, but in this particular case, our application is going to be the same. I know that a squared plus b squared must equal c squared, so I can fill in information with what I know and leave parts of the formula for the things that I don't know. In this case, 6 squared plus b squared, I don't know that yet, equals 10 squared. I can start to work that problem out. 36 plus b squared equals 100. And once I've done that, this simply turns into an algebraic equation that I'm working to solve. So that means I need to get my variable by itself. I'm going to do that by using our inverse operation to move things away. In this case, I'm going to subtract 36 on both sides. I'm going to know that b squared is equal to 64. And just like we talked about last time, we want to make sure we actually get b itself and not just b squared. So here b squared was 64, so that means I can square root 64 to find what b is equal to. And sometimes we end up with irrational numbers. Our last example was an irrational number, but sometimes we can end up with rational numbers as well, because the square root of 64 is 8. So in this case, I would simply know that side b for this triangle was equal to 8. Now, one of the critical parts for the Pythagorean theorem is to understand which sides of the triangle are going to be A, B, and C. So let's go ahead and look at that. We know our formula stays the same for any right triangle A, B, and C. A squared plus B squared equals C squared, but we have to know which side is A, which side is B, and which side is C in order to use this. So there's a couple of key vocabulary words to know when we're talking about the Pythagorean theorem. And the first of those words is kind of a tricky math word. It's called the hypotenuse. And the hypotenuse is the longest side of a right triangle. And if you noticed in the two examples that we did, the longest side of the right triangle is always in the same place. And it is always opposite of the 90-degree angle that is in the right triangle. You can always draw an arrow from the right triangle across, from the right angle across the triangle, and it will point at the hypotenuse. There's something else about the hypotenuse that is important, and that is that the hypotenuse is always going to be C. And that leads us to the legs. And the legs are going to be the two shorter sides. So the longest side is the hypotenuse, and the legs of our triangle are going to be the two short sides. And the two short sides always touch the 90-degree angle. The hypotenuse never does because it's opposite of the 90-degree angle. And the two short sides are always going to be A and B. And it doesn't actually really matter which side is A and which side is B. If you want to start establishing a pattern, I like to always just say that the shortest side is A and the middle side is B and the longest side is C, just to be consistent. But A and B, the legs are interchangeable because we're using addition for A and B. So those things are interchangeable. So I'm going to draw a couple examples here on our worksheet over here. And here's an example of a right triangle. I know that the hypotenuse is always the longest side, and it's always opposite of the 90-degree angle. So in this case, I'm going to draw an arrow that goes opposite of where that 90-degree angle is. Okay, so that is going to be my C. The two sides that touch the 90-degree angle are A and B. Again, I said I like to make the shortest side A and the middle side B, but that's totally up to you if you want to do that or not. A and B can be interchangeable. Now let's look at another example here of a triangle. So here's a different example of a triangle here, but our rules stay the same, right? C is always across or opposite of where the 90-degree angle is at, and A and B are the two shorter sides. Again, A and B can be interchangeable. I like to make the shortest side A and the middle side B, but because we're using addition, that means we can use the commutative property, and the order of those two don't actually matter. And here's one more example. I would look at C and realize that C is always going to be directly across from that 90-degree angle. That means A and B are my other two sides, and that helps you figure out which side is A, which side is B, and which side is C.